Good morning, students. Thank you very much, students, for clicking on my video. I'm your Nagini ma'am, chemistry mentor. In today's section, I'm going to discuss about the names of anionic complexes. Amma. This is the topic from the coordination compounds, 12th class, second PUC. Okay, na? So anionic complex. Okay, students are getting confusion. Students, the given complex is cationic complex, anionic complex, neutral complex. They are some students are getting confusion. Yes, so I'm going to discuss about the first anionic complex, how to write the name. Next, in the next video, cationic complexes, how to write name. Next, neutral complexes, how to write. Okay, the next bridging ligands there means how to write the name of the complex compound. I will discuss Nana. Okay, in this video, I am discussing about only anionic complex. Okay, anionic complexes. So now see, students, these are all the complex. Before all I wrote Nana to save just time. Okay, now see here, these all the complexes are how to identify. This is the given complex is anionic complex or cationic complex. How to identify that? We any salt you take, students, in any salt first cation will be there, next anion will be there. Just to keep in your mind. Now see, students, for example, NaCl salt I am taking. In NaCl salt, first sodium, it is a metal, chlorine is a non-metal, metal, sodium is a cation, correct? It is a cation, understanding? It is cation and chlorine is anion. Understood, amma? Cation. That means cation positive charge, chlorine is negatively charged particle. Cation or anion will be there. Understanding? So it is dissociates into Na plus and Cl minus. When dissolved in water, it dissociates into Na plus and Cl minus. That means first in any salt, students, first what will be there? Cation is there. Next anion is present. Just to keep in your mind, in any salt, first cation, next anion will be there. Now take this coordination compound. Coordination compound. Square bracket part is one part. This is first part. This is the second part. Are you understanding? Square bracket is there, na? This is completely one part, amma. This is outside the square bracket, front there here potassium. Understand? It is the first part. Now suppose this is the salt, students. Now here's starting what is there in every salt. What I told you, starting is cation, next one is anion. So potassium is a cation, this is anion. This is cation, anion. That means in the anion place, square bracket is there. In anion place, square bracket part is there. That's why these complexes are anionic complexes. Are you clear, students? Understood, amma? Okay, this is cation, this is anion. Cation, anion, cation, anion. So in any salt, first cation, anion will be there. So cation there. In anion plus square bracket part is there. That's the anionic complex. If suppose in the cation place square bracket part is there, that is cationic complex. Are you understanding, students? I will take just one example. PTNH36, PTNH36 Cl4. See this complex? First cation, next anion. So in the cation place, square bracket is there. That's why it is the cationic complex. In the cation place, square bracket there, that is cationic complex. In the anion place, in anion place, square bracket part is there, that is anionic complex. The square bracket part is one part you have to consider, one group. Okay, this is cation, anion. Cation, anion. First cation, next anion. In cation place, square bracket part is there, cationic complex. This is which complex? Cationic complex. Clear? Cationic complex. Understanding? So I am discussing here anion. Understood, students? Got clarity? Clear? This is anionic complexes. Okay, how to write the name of the complex? In rules I discussed you first. We have to follow the first cations are named first. Correct? First cation. Cation, which one, students? Potassium. So cation name is potassium, students. So first we have to write the name of the first here Nana. How to write the name of the complexes, Nana? IUPAC rules are there. That all rules in the last video I discussed you, students. Once please go through that video. Okay, that all the rules. Then you will get easily. You can easily write these all the names. Understanding? Right. Now see, students. Cations are named first. So first cation, which one, students? Potassium. So I am writing the name potassium cation over. Next, square bracket part is there. cation name is over potassium. Next, square bracket part. In square bracket coordination entity, this square bracket part is called coordination entity. So in this, what we have to write first? Number of ligand should write. Next, name of the ligand, name of the central atom, oxidation state of the central atom. This is the sequence. Yes or not? Here I told you in the last video, students, please. Last video I told you for in coordination entity, number of ligands, name of the ligand. This is the sequence you have to follow when you're writing the name of the complex compound. Number of ligand should write first. Next, name of the ligand. So first I'm going to write number of ligands. See here, how many ligands are there, students? 2 ligands are there. Number of ligands, name of the ligand, name of the central metal atom, oxidation state of the central atom. So number of ligands, how many are there? 2 are there. 2 means what prefixes we are using, students? What prefixes we are using? 2 there means what I told you, di. 3 there means tri, tetra, penta, hexa, like that. So here 2 are there. So that's a what prefix we have to add, student? What prefix we have to take? Di. Okay, di. Next, number of ligands over. Next, second one is name of the ligand, Cn. Cn means it is the negative ligand. Yes, it is the negative ligand, Cn minus. What is the name when you are writing the name of the ligand? Okay, in negative ligands, neutral ligands I told you. Okay, Cn minus I told you. See here, students, it is the last video. Cn, cyanide, Cn minus is there. Cyanide, ide is replaced by O. Okay, id is replaced by O. Cyano. Okay, so that's about we have to take, students. Cyano or cyanido also we can write. Cyanido. Clear? Cyano or cyanido. Okay, both are correct only. Now I am writing the cyanido. Okay, potassium di cyanido. So till here, name of the ligand completed. Next, name of the central metal atom. Name of the central metal atom. When you're writing the name of the central metal atom, you have to see the coordination zone. It is positive or negative or neutral. Now, see, students, it is the cation. This is anion. Are you clear? This is which one, students? Cation. This is which one? Anion. That means square bracket part is anion. That means it is a negative coordination zone. Anionic complex. Negative. If the coordination zone is negative, anion kada, it is negative. It is positive. Anion, negative. If the coordination zone is negative, then the central metal atom, to the central metal atom we have to add the suffix ate. Correct? Suffix ate we should add. Anionic, see here, last video I will show you. See here. If the coordination, when you are writing the name of the central metal atom, if the coordination entity is neutral or positive, positive means cationic complex. Now given complex is cationic complex? No, it is anionic complex, correct? Because in the anion place square bracket is there, it is anionic complex. So that's the second case. Coordination entity is negative, anionic complex. Then the metal atom, to the metal atom suffix ate we should add. Ate. That means titanium becomes titanate. Chromium, chromate. So like that. Here Ag is there. Ag means its Latin name is argentum. Argentate. Clear? What you have to write? Argentate. 8 we have to add. 8. After that, oxidation number of the silver. Silver oxidation number we have to find it. So what is the oxidation number of the silver, students? Oxidation number we have to find. Calculate. Potassium oxidation number 1 I will show you, students. Remaining directly I will take oxidation numbers. Potassium plus 1. Next, silver, we are going to find silver oxidation number 2. Cyanide oxidation number is -1. Okay, cyanide oxidation number -1 equal to 0. That means 1 plus Ag minus 2, 0. That means Ag oxidation number how much, students? +1. So this oxidation number how to write? After the name of the central metal atom, you have to write in the parenthesis. This number you have to indicated by Roman number. Clear this one? With Roman number you have to represent, you have to write in the parenthesis. That means in bracket you have to mention. Clear? Potassium dies, first cation name, next number of ligands, next one is name of the ligand, next name of the central metal atom. Next one, oxidation number of the central metal atom. This is the order, students, when you're writing the name of the complex. Completed. Now see the second one. First cation name, sodium. Okay. Next, how many? Next, what you should write? Number of ligands. How many are there? Two are there. So di. Cn. What is the name of the ligand? Cyanido. Next, name of the central metal atom. It is the gold, Rm. So what we have to write? Latin name Rm. Rate. Clear? Rate. Next, what is oxidation number of the gold, students? Gold. How to find it? Oxidation number. Sodium plus 1, gold plus 2 cyanides, oxidation number minus 1, 0. That means oxidation number of Rm is plus 1. Okay. So right here in the parenthesis with it is indicated by Roman number. Clear? So like this you have to write, students. Now see third example. Potassium. Here madam, 4 potassiums are there. We have to write tetrapotassium. No. Outside the coordination zone, how many are there? Just you have to write only just name of the element, Nana. Okay. You should not write di like that. You should not write K4. K4 is nothing but potassium. Just write potassium. Okay. Tetra. How many cyanides are there? 4 there. So tetra. Cn is nothing but cyanido. Clear? So number of ligands over, name of the ligand over. Next, name of the central atom. Name of the central atom nickel kada. Nickelate. Clear? Nickelate. And oxidation number of the central metal atom. You have to find the oxidation number. What is oxidation number? K4. 4 potassiums are there. 4 into plus 1. Potassium first group element. Oxidation number is plus 1. Nickel X. Nickel we are going to calculate. Plus 4 cyanides are there. 4 into minus 1 equal to 0. That means 4 plus nickel minus 4 equal to 0. Are you understanding? Then 4 get cancelled. Nickel oxidation number is 0. So just write that nickel oxidation number in the parenthesis in the open bracket 0. Clear? So like this you have to write, Nana. Now see fourth example, students. Here fourth one. Potassium. 6 fluorines are there. 6 fluorines means hexa. F means what, students? What we should write? Florido. Clear? Florido. 6 means number of the ligand 6. 6 means what is the prefix? Hexa. F means florido. Okay. F means what I told you, students, when you are writing the name of the ligand. Negative ligands I told you that you have to follow, students. Negative ligand F minus fluoride, florido. Okay. Florido we have to write. So this is florido. So name of the ligand over. Next, this is the name of the central metal atom. Platinate. Clear? Oxidation number of the central metal atom. How much, students? We have to find it. 2 potassiums, 2 plus platinum, 6 fluorines, minus 1 equal to 0. Then platinum, how much, students? 2 minus 6 plus 4. Clear? Here platinum oxidation number is how much? 4. That you have to write in bracket. Over. Okay. Now see this one. Potassium. Here 3 oxalate ions are there. Try C2O4 oxalato. Clear? This is number of ligands completed. This is the name of the ligand, oxalato. Next, name of the central metal atom, chromium, chromate. Next one, oxidation number. Oxidation number, how much, students? Potassium plus 1, oxalate ion minus 2. Okay, 3 into minus 2, minus 6. So here plus 1. That means plus 5 you will get. Are you clear? Oxalate ion 3 plus, this is plus 3. This is minus 6 kada. 3 into minus 2. This is 3 plus x minus 6. That means x is equal to plus 3. Clear? So oxidation number, how much, students? 3. Okay. Now see next example. potassium, potassium. Here, see students, still now only one ligand is there. That's why we wrote directly ligand name. But here see, in the square bracket, two ligands are there. More than one ligands are there. So we have to follow the alphabetical order. Alphabetical order we should follow, students. Okay. Now see, here potassium cation, potassium. Okay. Next, here this is chlorine. This is the chloride, chlorido. Next, this one is amine. It is a neutral ligand, amine. Special names are there not for neutral ligands. Okay, now for neutral ligands, I gave you special names, correct? Okay, now neutral ligands there means in the case of names of neutral ligands, NH3 what we will call amine. Understanding? This is the last video, students. Amine. Okay, that you have to take amine. So potassium completed. Next one, this is amine, this is chlorido. So which letter is coming first? Alphabetical order. Amine is coming first, so amine, right? When you're writing the name of the ligands, more than one ligands there, you have to follow the alphabetical order. So first amine should write, only one amine is there. As it is, you should write amine, completed. Next ligand is chlorido. How many are there? Three are there. Trichlorido. Till here, name of the ligands completed. Number of ligands over, name of the ligands over. Next, name of the central metal atom. Platinum. Platinate. What is the oxidation number of the platinum? Potassium 1, platinum 3 chlorines, 3 into minus 1. Chlorine oxidation number minus 1. NH3 is a neutral ligand. Oxidation number is 0, equal to 0. That means platinum 1 minus 3 equal to plus 2 here. Oxidation number is how much, students? 2. Right here in the parenthesis. So this is the name of the complex compound. Now see next name. This is potassium. So first cation name completed. Now anion name should write. In the anion name, 4 chlorines are there. That means tetra. Number of the ligand completed. Name of the ligand chlorine, chloride, chlorido. Correct? Chlorido. Nickelate. As it is, you should write nickel. Nickel. After that, you have to add the suffix atom. So what is the oxidation number? 2 potassiums are there. 2 into plus 1, 2 plus nickel X. 4 chlorines are there. 4 into minus 1. Then X minus 2 equal to 0. X is equal to plus 2. So what is the oxidation number? Plus 2. Clear this one? So like this you have to calculate, students. And next, third example, potassium. Next, this is oxalate, this is amine. Which is coming first, students? Alphabetical order, because here more than one ligands are there. This is amine, this is oxalate. Amine is coming first. Alphabetical order, first letter A, amine is coming first. Next, oxalate O is coming next letter. Okay, so amine. How many amines are there? 2 are there. That's why prefix we have to take diamine over this one. Next, this one, dioxalato. Clear? Diamine dioxalato. Okay. Next, this is cobaltate. Clear? First we are writing number of ligands, name of the ligand, amine. Alphabetical order, 2 are there na? First we have to write this, next this one. Next, cobaltate. What is the oxidation number? Potassium 1, cobalt X, 2 oxalate ions, 2 into oxalate ion minus 2, ammonia neutral ligand 2 into 0, 0. Then what we will get? 1 plus x minus 4, 0, x minus 3, 0, x is equal to plus 3. So oxidation number is plus 3. You have to write in the Roman number. Write in the bracket as Roman number. Clear? Understood, students? Now see here, fourth one, sodium. It is the cation. So take here sodium, cation name first. Next, number of ligands, 6 are there. Hexa, NO2, nitrite group, NO2, nitrito, otherwise nitrito. Clear? So NO2 group is there. What we will call? NO2 group is there. Nitrito, nitrite, nitrito. Okay, nitrito. Next nana, central metal atom cobaltate. Cobaltate. Central metal atom is cobalt because it is anionic complex, so that's why we have to add suffix ate to the metal atom. Cobaltate. And oxidation number. What is oxidation number? 4 sodiums are there. 4 into plus 1 4. Cobalt X. Next 6 NO2 groups. Oxidation number is -1. Nitrite. So then 4 plus x minus 6 equal to 0, x minus 2 equal to 0, x is equal to plus 2. So what is the oxidation number? Plus 2. Clear? Now last example, see students, potassium. Take here potassium. How many? Next, number of ligands should write. Total 6. Hexa. Fluorines. Fluorine. What is the name of the ligand? Florido. Clear? Florido. Chromate. 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 What is the oxidation number? You have to write 2 potassiums. 2 plus x plus 6 into fluorine minus 1 oxidation number. Okay. Oxidation number is -1. Then x plus x minus 4 equal to 0. X is equal to plus 4. So what is the oxidation number? Plus 4. So this is about the names of the anionic complexes. Understanding, students? So you can easily understand. So in any salt, students, first cation will be there, next anion will be there. In first place cation place square bracket part is there, that is cationic complex. If suppose second place square bracket part is there, this is cation, this is anion. In anion place square bracket part is there, that is anionic complexes. Are you clear? So first we should write the cationic name of the cation, number of ligands. Okay, now in the coordination zone, number of ligands, name of the ligand, name of the central atom, and oxidation state of the central atom. This is the sequence. Are you clear? So what is the sequence we followed, students? First cation name. Okay, cations are named first. First cation name should write. Cation name. Next what should write? Number of ligands. Number of ligands should write. Next one, name of the ligand. Clear? Name of the ligand we should write. Okay, name of the ligand. Okay, in anionic complexes, name of the ligand we have to add 8. Number of ligands, di, tri, tetra, like that we have to use. Name of the ligand after oxidation state of the name of the ligand after name of the central atom. Name of the central metal atom. Okay, name of the central metal atom you have to add. Name of the ligand, not atom, sorry. Name of the ligand you should add. Okay, fluorine there means fluorido, cyanide there means cyanido, like this. Here atom, what we should add, students? 8 we have to add. Next, last one is oxidation number of the metal. Oxidation number of the metal we should write in open bracket. Clear? This is the sequence. First cationic name, next number of ligands, name of the ligand, name of the central metal atom. Okay, when you're writing the name of the central metal atom, for in anionic complexes, suffix 8 we should add, and letter oxidation number of the metal we should calculate. Clear, students? I hope you understood this video. If you like this video, students, please like, share, comment and subscribe my channel. Thank you very much, students.